Okay, guys, we're going to go back to PowerPoint number 2. Just to refresh your memory, we finished up talking about the process of rigor mortis. And remember the time frames of that, if we're talking about, a typical ambient temperature, like the temperature of your house or the temperature of your classrooms, it starts about 30 minutes after death, and then it is fully set, meaning the person is in full rigor and all of their muscles are literally like cement, by 12 hours, and then it remains that way for an additional 12 hours. Okay, so if a body is in full rigor, what that means is that person has been deceased for between 12 and 24 hours, typically. Now remember, this is why it's important to measure the ambient temperature, because it can have a faster onset when there's higher temps. It can have a slower onset when it's really cold. But typically that's the time frame. Then it starts to go away in the reverse order that it formed, and then it's completely gone by 36 hours, meaning that the muscles are relaxed again. Okay, so now we're gonna move on to the process of Algor Mortis, okay? And remember, this is the YouTube-friendly PowerPoint right here, so you can refer to the one with pictures, okay? So the second way, or the second process that we look at to try to determine how long someone has been deceased is a process called Algor Mortis, okay? And it's not liver. It has nothing to do with the organ, the liver. So as we talked about before, when a person dies, their heart stops pumping, and that means their blood is no longer going to be moving, okay? So blood cells, and specifically here, we're looking at red blood cells, but even though they're small, right? Cells are tiny, they still have weight or mass, and so they're still going to be acted upon by gravity. So what Algor is it is blood pooling according to gravity, which means that it's going to go to the downward most surface, and that's where it's going to start collecting. So when we see Algor, it tends to, basically darken the skin. It's easier to see on people who are light-skinned, but you can see it on people who are dark-skinned as well, simply because there's a different, the differential tone between where Algor is and where it isn't. So wherever Algor Mortis has settled or begun, the skin is going to look darker, and you'll see some examples in the PowerPoint. On light-skinned people, it can actually look like a bruise. It can look dark blue or purple, but you can tell the difference that it's not a bruise because it's widespread, basically. So Algor starts immediately after death because the heart is no longer pumping, so that blood is going to start to settle, and just like rigor mortis, it's going to be fully set by about 12 hours after death. This is what we call Algor being fixed. Okay, when it's fixed, that is what it happens at about 12 hours after death, and what that means is that those blood cells are not going to move anymore. Okay, you can also tell about the environment that the person died in sometimes by looking at the color of the Algor Mortis, and I'll show you an example of that. Okay, so I'm going to refer you to the PowerPoint, and we're going to look at some examples. So in slide 20, okay, so here is an example of Algor, and actually this is a young male, and his left arm was behind his back. And so that's where you see that big white mark. Then it's basically because he was laying on his arm. You can also see a white mark on his right scapula or shoulder blade. So that means that that part of the body was resting on a hard surface, basically. Okay. So also his Algor is very pronounced, because he's a Caucasian person, so it's much easier to see. But also you can see it has that like bright, purplish discoloration, but, and almost like leaning towards a reddish. And that's what Algor looks like when a person dies out in extremely cold temperatures. Okay. And states here, in the photo, he'd been dead only 12 hours, but the body was subject to extremely cold weather conditions, which affected the hue. And in this case, they say the lividity. Lividity and livor mortis are the exact same thing, okay? And the other thing I want to point out, there we have a name for these white areas. It's called blanching, which I'm going to get to in just a slide or two. Okay, so here we have another example on the next photo, slide 21. So this is a female, looks to be an elderly female, and looking at this picture, you know, we're not sure about the cause of death, right? So you can't assume anything, but it appears that maybe she could have had some type of, you know, heart attack or some type of natural event. And then she was standing over the sink at the time and then basically, you know, kind of hunched over and died. Okay, so that's one hypothesis. So if that is the case, if this is the position in which she died, then we should expect to see livor on her lower legs and in her feet, right? Because the blood is going to be acted upon by gravity and it's going to go to the lowest surface of the body. And because the bottoms of her feet are in contact with the floor, which is a hard surface, we would expect that you wouldn't see blood settling there, okay? And you would see what we call blanching. So let's take a look. And sure enough, there is blanching that is occurring basically on the soles of her feet, you know, particularly on the balls of her feet, meaning that she was probably leaning forward. So she, you know, that was the position that, you know, she was in, or either she died that way or she was put that way almost immediately after death. And this is where livor mortis became fixed. And the blanching helps us learn about that positioning. So when you look at the combination of livor mortis and rigor mortis, it can be very important in determining, okay, is this a staged crime scene or was this person moved after these processes started to set in? Because if you have a person that's in full rigor and the lividity is fixed and the patterns don't make sense, that means that, okay, someone moved them about at least 12 hours after death. Okay, so this next photo, we have 6 pictures, and I'm gonna walk you through these. Okay, first of all, we have this gentleman on the left. Okay, so upper left, this is a young man found at a scene. I don't know what his cause of death was, but what I wanna point out is when you look on the left center picture, you can see a handprint. Okay, so whether it was the detective or the EMT that, you know, pressed their hand on there, they're trying to see if lividity is fixed. And in the upper picture, there's no handprint. Down here, they were able to press onto the skin and they could physically see their handprint. What that means is that livor mortis is not yet fixed because the red blood cells are still movable. So that means that this young man has been dead less than 12 hours. Okay, and eventually that handprint would go away. I mean, you guys can prove this on yourself. You know, push on your skin really hard. You're gonna see your fingerprint there for a second, but then it's gonna go away because your heart is pumping, okay? So, you know, your blood cells are not gonna settle according to gravity. So, you know, you can prove it on your own skin. And then I just wanted to point out the lower left, this is when the young man was taken to the medical examiner's office. And whenever a person, before their livor is fixed, and if they are laying on their back, when that 12-hour mark hits and it does become fixed, you're always going to see this butterfly pattern. And it's basically because that's where the scapulas are hitting. Okay, you know, you probably heard the term flat on your back. Okay, but none of us lie exactly flat on our backs because we all have curvature to our spines. And so when you are laying on your back, the parts that hit are normally the buttocks and then your shoulder blades. And so that's where you're going to see blanching. Okay, so here is what it looks like with the shoulder blades. You can see it also on this female right here. And then farther down, you can see that, yep, she also has that blanching pattern on her buttocks. And that's because that's where the pressure is when a person is on their back. Okay, so speaking of this female in the lower right, so this is actually the same person. So this is where lividity can give you a clue as to, was this person in this position when they went into full rigor and full liver, or had they been moved? And did death occur in less than 12 hours? Okay, so this is how she was found. I think this was in like a parking lot behind a bar. And she's on her stomach, but you can see her right arm, and specifically it looks like, part of her hand, fingers and thumb are underneath her torso. And so obviously her body weight is going to be putting pressure on whatever part of her hand is underneath there. And so you're going to see blanching. And sure enough, that's what we see. Okay, so wherever there is weight, you're not going to see the blood pooling and settling. And also, when they touch this, there's no fingerprint. So that means that lividity or livor mortis is fixed. And so she had been dead at least 12 hours. So livor mortis is not like rigor mortis in the sense that it goes away. The only time frames they can tell you is if it's fixed, if those blood cells aren't moving, what that means is that the person has been dead at least 12 hours, okay? But it stays fixed. It doesn't go away. Okay, this next picture is where both rigor mortis and livor mortis can be very useful. So this is a victim of a homicide that was found basically thrown in a ditch along, an interstate or a highway. And when you look at her positioning, okay, so this looks like she was curled up into kind of a fetal position, and the blanching pattern from the livor mortis tells you that she was laying on her left breast, and then also it looks like her right cheek was face down. Okay, so I would imagine that she was probably killed and then put into the trunk of a car, and to fit in there, she had to be put in that position, and then that is where she went into rigor mortis, and also where livor mortis became fixed. Okay, so the livor pattern would tell the investigators that, yep, she was dead at least 12 hours. The fact that she is in full rigor tells them that she has been dead between 12 and 24 hours. Okay? So, but the other thing I want to caution those of you who are going into law enforcement, keep in mind, things can be staged to look like something else. Okay, so, you would look at this victim and think, well, she's naked, she was murdered, she was thrown along the highway. This could be a serial rapist, serial murderer, and maybe it was just a victim of opportunity. But keep in mind, this could also maybe be a case of domestic violence where the boyfriend or husband wanted it to look like a murder, and so therefore they undressed her and then dumped her body like, oh no, it was some stranger that did this. Okay, so I'm sorry. Keep in mind that can be the case as well. Okay, so both of those in terms of position can be very informative. Okay, next picture. This was a man who died of natural causes, okay, and also he's in full rigor, and the livor pattern is fixed, so that means that he, in terms of livor mortis, he's been dead at least 12 hours. If he's in full rigor, then he has been dead between 12 and 24 hours. And notice how you can even pick up patterning. So you can see the shapes of the tiles on that floor in the lividity pattern. Okay, but this was actually, a natural death. Okay, so that's livor mortis. And then our last topic for this PowerPoint is Algor Mortis. So Algor Mortis refers to the temperature of death. So a typical temperature in a human is 37 degrees Celsius or 98.6 degrees Fahrenheit. And then when someone dies, right, we no longer have that process of homeostasis. And so our bodies are going to start to cool until they reach the temperature of the surroundings. And the typical time frames are that the body will cool approximately 1 to 1.5 degrees Fahrenheit, until it reaches that ambient temperature. Okay. However, once again, this is something that is highly dependent on the environment in which the body is found. So future investigators keep this in mind. If, a person is found inside, you want to know, does that house have heat? Does it have air conditioning? Is it cycling between temperatures? Were there windows open where the temperature would have been lowered? Also, was that person sick? Did they have a fever? So now maybe instead of starting at 98.6, they were at 103 degrees Fahrenheit. And obviously that's going to make a huge difference in terms of time of death estimates. So Algor Mortis, because it is so highly dependent on the environment, in fact, the state medical examiners in the state of Iowa have decided that they really don't use Algor Mortis anymore. Okay, some states do, and if you learned anything from the death investigation video, it's that things can vary widely from state to state. So, for example, in California, the Los Angeles County Medical Examiner's Office does use Algor Mortis as a calculation, and so they require their investigators to take a liver temperature. Now, we're not talking about liver, we actually are talking about the organ, the liver. And so the investigator will insert basically a meat thermometer. Okay, I'm glad it's not around Thanksgiving because I would ruin Thanksgiving for you, but it's not some special death investigator thermometer. It's basically the same thing that you can buy at Walmart to put into your Thanksgiving turkey to find out if it's at the proper temperature internally. And the next video assignment I'm going to give you, which is a documentary about the Los Angeles coroner's office, you're going to see a case where a death investigator actually does that. So you'll see them push a meat thermometer into the abdomen of the decedent, and then they will take a body temperature. Okay, and from that they can make calculations, and then they should also be measuring the ambient temperature from that. But like I said, the person that they find in the video could have been really sick and they don't know that. Okay, so they could have had a higher fever, and that's why it's so dependent. The other reason that it's not used by medical examiners in Iowa is that it's really not a good idea, especially when you're dealing with an unattended death or something that could be criminal, to introduce any type of sharp force artifact or injury into a body. Okay, what if this person had died of, and you'll see in the video, the person probably died of chronic alcoholism, which obviously affects the liver. And now you're putting this sharp force injury into the liver, which could obscure other findings. There might be a tumor in there. There might be scar tissue. It might not be anything criminal, but it's still, why introduce a sharp force artifact if you don't have to? Okay, and so that's another reason why the Iowa medical examiners say, no, it's just not that reliable. It doesn't give us enough good quality information for us to use it. But different states do different things, so it is used in California and in other states. So, okay, so those are the three mortises. So I want to mention some other things that can be used, okay, other factors for estimating the time of death. One body fluid that can be sampled after death, and it's commonly sampled for toxicology to look for drugs and medications, is something called vitreous humor. Okay, so humor is Latin basically for body fluid. So vitreous humor is ocular fluid, or the liquid within the eyeball. Okay, so for those of you who go for an eye exam And I remember I used to hate this because they had a machine where they would have to put a puff of air into your eye, and I'd always blink my eye. I always screwed it up. Now they tend to put numbing drops in and they just take a little measurement. What they're doing is measuring the pressure of that fluid within your eyeball, because too much pressure can result from an eye disease called glaucoma. And if it goes untreated, then, it can result in blindness. So that's the same fluid that is being, the pressure is measured in living people to look for glaucoma when you go for an eye exam, but it can also be withdrawn from the eyeball and tested. And what has been found is that potassium levels will rise in that ocular fluid at very precise intervals after death. So if, your decedent still has eyes, you can potentially take that fluid and not only test it for drugs of abuse or poisons or even medications the person was taking, but if you measure the potassium, then you can plug it into a standard curve and it'll give you an estimated time of death as well. And of course that has to, there is an error factor. It has to be correlated with other sources of both medical evidence and investigative evidence like talking to loved ones and witness statements. Okay, then we have stomach contents, okay? And this is another thing on TV that is just maddening. And once again, Law and Order SVU, by far the worst forensics, I think, on TV. So I remember watching an episode and it was like, oh, well, I looked at the stomach contents and obviously the person had prime rib and it was rare and it looks like they had, au gratin potatoes and they were drinking wine and it was a Merlot. Okay, you know what? We've all barfed, right? We all know what stomach contents look like. A pathologist can determine, it looks like it's meat, okay? And maybe like beef versus chicken. Maybe they can identify some vegetables if they are not fully digested, but they're not going to be able to tell you what kind of wine, the person drank. They can probably say, oh yeah, I'm picking up some type of alcohol-related odor. Pathologists love to smell things, okay? Just so you know, they're a special breed. But it's not going to give you their precise meal, just so you know, okay? The best description I ever heard of stomach contents was a pathologist in Chicago who said, yeah, I just smell it. And if it smells like chicken wings, the person probably had chicken wings. So like I said, they are a special breed, okay? But what can be informative are the timelines, okay? So on a typical day, let's say that you're not feeling a lot of stress, there's nothing big going on in your life, you don't have a big exam or a job interview or whatever, it's just a typical day. So if you eat lunch, let's say at noon, the contents of your stomach are gonna empty into your small intestine by about 3 p.m., okay? So on a typical day where a person is not sick, they're not stressed, it's gonna take about 3 hours. So if the person's stomach is empty and everything is in the small intestine, you could say they last ate, about 3 hours ago. The next thing to look at is the small intestine empty? Okay, because in the small intestine, it's going to take about 24 hours for the contents to make it to the large intestine. Okay, so, and during autopsy, pathologists open basically from the esophagus all the way through the loops of, they go through the stomach, the small intestine, the large intestine, and they open it up the entire length because they're looking for tumors or adhesions or, maybe cuts or some type of other injury to that. So if the stomach is empty, basically, the person has not eaten within about 3 hours, okay? And that's a person with typical health. Once again, it can vary. If the small intestine is empty, that means that person has not eaten for about 24 hours. And then also, then we have the large intestine, okay? If the large intestine is completely empty, that means that that individual probably has not eaten within 2 to 3 days. So this can become very important, especially in factors of, say, child neglect or elder abuse, where, you know, the caregiver isn't feeding the person, or a person isn't feeding their child. And, you know, if their statement is, oh yeah, you know, she had lunch today. And if the large intestine is empty, now come on, you haven't fed your kid for about 2 to 3 days, okay? If the small intestine is empty, you haven't fed them anything for about 24 hours. So, you know, stress can actually slow down the stomach emptying, because your body, if it's feeling a lot of stress, it'll be like, you know what, I need to get blood to my heart and my brain and my lungs. Stomach, you can wait. Okay. But if you've ever had some type of virus, you know, like what we commonly call the stomach flu, it can also empty faster when the person is sick or has a really high fever. Okay. So you do have some, you know, conditions can cause varying of that, but these are typical time frames. So 3 hours for the stomach to empty, 24 hours after that for the small intestine, and then about 2 to 3 days for the large intestine to empty. Okay, final thing that I want to show you, or final way that can indicate, you know, roughly time of death. And remember, the investigator is looking at all of these things, okay? And they're trying to put together a general estimate by looking at rigor and liver and Algor Mortis, if they happen to use that, and then all of these different things. So the last thing I want to mention is something called take noir. And these are, you know, normally they're darker in color. So I know it says here black. They can also vary, you know, like a brown color. But basically, it's the cornea drying. Okay. So another thing on TV is, you know, people always tend to die with their eyes closed, you know, fully closed. And while that can happen, a lot of times there is a little space between the eyelid and the bottom of the eye. And so air can get in there and the surface of the cornea will start to dry out. And that is all take noir is. It's basically just the drying out of the cornea after death because it's exposed to air. So if you look at the final picture in the PowerPoint, the take noir are those darker, kind of blackish, brownish lines. And all that means is that that person's eyelids were not fully closed. Okay. And we don't have set time frames. So it's not like these are going to form instantaneously at 12 hours after death. No, the drying will happen over time after the person dies. The most you can say is that if you see take noir, that person has been dead for several hours. And we really can't get any more specific than that, but it can be informative and, you know, tell the investigator that, okay, we're not looking at a person who died an hour ago. They have been like this for several hours. And so it's just one more piece of information along with liver and rigor and, you know, other areas of investigation. Okay, so that wraps up PowerPoint number 2. Hello. And now we're going to head on to our final PowerPoint and hopefully our final lecture. And that is on what happens basically after 36 hours. Okay, thanks very much.